Okay, hello all you Algebra 2 students. I wanted to give you an opportunity to check your work in case we didn't get a chance to finish all the problems before class let out on Thursday. So I'm going to go ahead, you can scroll through the video if you like to find the problem numbers that you need. I'm going to go ahead and start with 1 and get that recorded for you all the way through 20. And of course, we didn't have all 20 assigned, so we'll just do the ones that were assigned. I have those circled on the test. And I have some graphs down here. If you need to get some graphs, you can find those through your, just Google them and find some. I called these, I think when I found these, they were mini coordinate planes. Comes with 4 to a sheet, and if that's helpful, you can do that as well. And then I'm going to do the same thing for test 5, but I'm going to make that a separate video. So there'll be 2 videos, one for test 4 and one for test 5. So let's go ahead and get started. So on number 1, it says after the storm, I'm going to underline after, the number of destroyed flowers was 240% more than before the storm. If 68,000 were destroyed after, so I'm going to box that actually, how many have been destroyed before the storm? Okay, so we're looking for the number of flowers that were destroyed before the storm. So we see we have some after information and some before information as well. So this is one of those percent problems. I'm going to go down here and we'll start number 1 right down here. Okay, so we set this thing up. First of all, we're going to set this up as a percent. So anything out of 100, right? We know that. We set this up as a multiplication of our of number will give us our is number. So let's fill in the parts that we know. Now keep in mind that since we're looking for information regarding before the storm, the number of flowers that were destroyed before the storm, that's going to be what our of is representing here, because we're looking for a percentage of a number that will equal the number of flowers. We're looking for the before number. So let's fill this in. It'll make a little bit more sense. Okay, so with the percent, it says that it was after the storm, the number of destroyed flowers was 240% more than before. So that means it's not going to be 240 over 100. It's going to be 340 over and above the 100, because 240 is the increase above the 100%. Okay, so we have 340 over 100 times, we'll call of the B letter for before, and the is number is going to be 68,000. The 68,000 is the after. So here we have, this was our after percent, and this is our after actual number. Okay, so those are both after, but what we're looking for is the before number. So now we can solve this thing using our algebra skills. Okay, so let me rewrite this down here. 340 over 100 times B equals 68,000. All right, so to get B alone, I'm going to multiply by the reciprocal, because that's going to turn into 1. 100 times 340 is 34,000, and 340 times 1,000, 100 is 34,000. We simply cross cancel those to make it easy, and we're left with B on this side. And then of course with algebra, we have to do the same thing on the other side. So we're going to multiply by 100 over 340. And when you do that, you're going to end up, we can cancel here. 340 goes into 341 time, it goes into 68,200 times. So we end up with 20000. Okay, so to answer the question, how many flowers had been destroyed before the storm? It was 20,000. That's number 1. Let's look at number 2. Scroll up here, number 2. A number is doubled and then the product is increased by 6. This sum is then multiplied by -3, and the result is 54 greater than 3 times the opposite of a number. Okay, so we're going to kind of chop this thing up a little bit. A number, we're going to call that n, is doubled. So that means it's going to be multiplied by 2, right? So I'm going to go down to the bottom here on number 2. If you have your test in front of you, you can keep looking right there. So we have 2 times n. A number is doubled, and then the product of that is increased by 6. So the product of 2 times n ends up being increased by 6, so we add 6 to that. Then we're told that this particular sum is then multiplied by -3. So we multiply this with a -3. Okay, and the result, so now we're looking for the result, which means we're looking for the other side is, and is always means equal to 54 greater than 3 times the opposite of the number. Well, remember, n was equal to the number. If I'm looking for the opposite of that number, we're looking at a -n. So what did it say? The result is 54 greater than 3 times the opposite of the number. So 3 times the opposite of the number would be 3 times a -n. And that is supposed to also, on the end of that, we have to tack on there the 54, because it says the result is 54 greater than that. Okay, so knowing that now, we can actually solve this equation for the missing number. So let's work that through. And we're going to look at this. I'm going to distribute. I'm going to have a -6n minus 18 equals -3n plus 54. We keep on working this through. I'm going to try to get my n's on the same side. So I am going to add 6n to both sides. It wouldn't matter which one I move. I could have moved the 3n over to the other side. But the reason I want to do this is it'll keep my n positive. It doesn't really matter. We can always rectify that at the end. If you end up with a -n, we can still work that through as well. And then I'm going to get 54 onto the other side. By subtracting it to both sides, I wanted to make sure I keep my equation in balance. And I'm going to have a -72 over here. We'll divide both sides by 3. And when you do the math on that, you're going to end up with a -24. So n is equal to -24. So box your answer in, and that's number 2. Let's see here. I don't have 3. We have number 4. Okay, I'm going to go up here and write on the test. This was the one I was trying to draw out in class, and I didn't do such a great job. So I'm just going to do the work right here on the test because it looks like there's enough room to do that. Okay, so one of the things that we notice, and we have to remember, this is an inscribed angle because its vertex touches the exterior of the circle. It's not a sector. Remember, a sector looks like this. It goes from the center of your circle. It makes like a piece of pie, okay? I suppose the other one could be a piece of pie too, but somebody was being selfish by cutting a humongous piece from one side of the pie to the other. This is called an inscribed angle here. When it touches the exterior of your circle, it's an inscribed angle. There's a rule about the inscribed angle. I can figure out the degree measure of C by knowing what the degree measure of this arc is out here, okay? We always look at the inscribed angle, and it's always going to be half of the arc that's included in that inscribed angle. So if we divide that by 2, we get 65 degrees. So C is equal to 65 degrees. Okay, now to find D, because that's what we have to find, that's C, now we have to find D. All right, so I notice I have a D here and a D here. So the degree measure around my circle, we discussed in class today, all the way around my circle, all the way around, is 360 degrees. Okay, I know I have this 130 right over here part. That's this part, that arc there. The other two arcs, this one here, let's see if I can put this in a different color for us. This will be in green. Okay, is 3D minus 7. And this one here is 4D plus 13. So really, all 3 of those around the circle should total the complete degree measure of that entire circle, which is 360 degrees. So let's set this up as an equation. We're going to take, let me change my pencil back to, we'll go to blue. We're going to use the 3D minus 7. Let's add to that 4D plus 13, and we'll add to that 130. I actually need to move this down slightly, so let me rewrite this down here where I have some room. Let me find the most room. Here we go. Okay, so let me quickly write that. 3D minus 7 plus 4D plus 13 plus 130 is going to equal the total measure around our circle. So there's our equation. So now we just drop the parentheses here. And let's do our algebra. So I'm going to combine like terms. I have a 3D plus a 4D. So I have 7D here. I have 3 constant terms. I have a -7, a positive 13, and a positive 130. When I put those together, I'm going to end up with 136 equals 360. Okay, let's subtract the 136 from both sides. And when I do that, I get 224 on this side and 7D. We're going to divide both sides by 7 so we can get D isolated. And we end up with 32 degrees if you put that in your calculator. So there's D and there was C. And that's how you do number 4. Okay, the next one, number 5. Okay, there was a couple things that you guys actually found a simpler way to get to this. Let me think what you did. I want to see if because I did it slightly different. Well, let's fill in what we know. So we have XY as a segment that's drawn along one side of a triangle. If B is 150, right here, and C is 70, then what is A? So let's see. I think you guys used the remote angle theorem. I did mine a little bit differently. I guess it doesn't matter. I'm just going to show you how I worked through this. I noticed that if this angle over here is 150, then I knew that this one had to be 30 because that's a linear pair, right? And then I also can see that I have, in the inside of the triangle, I have 70 and I have 30. Now, because of that, we also will know that those are remote angles. Remote angles to my exterior angle of A. I add those together, and that will give me the measurement of angle A. Actually, I think I even did it slightly different in class today. Okay, but angle A is 100. There's another way you could do that as well. I could simply look at 70 and 30 and figure out this third angle would have to be 80, right? Because I have to total 180 on the inside of there, which then, of course, would make angle A 100 because there's another linear pair. Okay, and I think you guys learned that in that new geometry that you were in, and that was how you knew that. Okay, so let's look at number 6. Number 6 says, find the area of this triangle. These dimensions are in centimeters. All right, so to find the area of this triangle, I'm going to need to, I don't know the height. And remember, in order to find the area of a triangle, we have to use base times height divided by 2, or we could just say 1/2 times the base times the height. But I don't have the height. I have the base, which is 20, but I don't have the height. So I need to make a line in here. I'm going to make it a perpendicular line so that I know it's coming down straight, making a right angle here. Now it's cut into 2 different triangles. My line looks a little bit crooked here, but let's say I came right down in the center, and I'm going to make this side 10 and this side 10 in my triangles. Cuts it in half. Okay, and I know it's isosceles too, remember that. So if my sides are the same measure, I know that it's going to make 2 equal line segments down there when I cut that triangle in half. Okay, so now I just need to figure out what the height is. So we have to set up an equation to do so. And we can use the Pythagorean theorem, which says leg squared, or we say a squared plus b squared equals c squared, which means one leg squared plus the other leg squared equals the hypotenuse squared. Okay, so what do I know here? Where's my hypotenuse? Right over here. So just so we can remember, the hypotenuse is always directly across from the right angle. So a squared is going to be one of the legs, which is going to be 10 squared, plus the other leg, which we don't know. That's what we're trying to find out. So we're going to call that h squared for height. And then c squared is the hypotenuse, which is 15 squared. Now when you do the math on this thing, we just have 100 plus h squared equals 225. We'll subtract 100 from both sides, and we'll be left with 125 here. We're going to take the square root of that so we can eliminate our square there, and that'll give us our height, which is going to be 5. Actually, yeah, what you're going to get is 5 square roots of 5. That's the height, and that's what we were looking to get in order to find the area of this triangle. So now there's my height. So I have a value for h. So the area will equal 1/2 the base times the height. The base is 10, and the height is 5 square roots of 5. All right, when you do your math here, I'm going to go ahead and do a little cross canceling just to make my multiplication easier on myself. I'm going to have 5 times 5 is 25. I'm sorry, 5 times, what did I do there? Oh, whoops. Oh, wait a minute. Oh, I'm sorry. Got to back up. Let's go back. I made one mistake here. I'm looking for the area now, and I should write this down. We're looking for the area of the big triangle, which would be the whole thing now, because that's what they were asking. Here I was trying to find the area of just one side of it, which I guess I could have done and then doubled it, but let's make it easier on ourselves. So area is going to equal 1/2 the base, which is 20, times the height, which is 5 square roots of 5. Now let's do some cross canceling. My area is going to be equal to 50 square roots of 5. That feels a little better. Centimeters squared. Box in my answer. There you go. All right, let's move to number 7. Find the equations of the lines A and B. All right, so if you look at A, it's a little hard to tell, but it's right here. And if you notice what that's doing, it's a horizontal line with y remaining the same. The only value that's changing is the x value on this line. Okay, so we notice that it's on the y-axis. So this one's going to be y equals, and we find where it is. This is at -2, and that is the equation, y equals -2. Okay, the next one's a little slightly different. So what we're going to look to do on for the line that's titled B here is we, first of all, want to keep this in mind. This is going to be for B. And we're going to write the slope-intercept form, which is always mx plus b. This m represents the slope, and b is the y value of the y-intercept. Remember, the y-intercept, or this value here in our equation, b, is where the line crosses on the y-axis. So let's find that. So on B, I can see right here, the line is crossing the axis at exactly 0, 1. Okay, so that's the y-intercept. Let me just kind of write that over here. So the y-intercept is 1, which is B, but it's the y value in that set of points right there. So we grab this 1 and we place it right there. Now we have to figure out the slope. How do I figure out the slope? We talked about this today as well. The slope is always going to be rise over run. So let's see. If you start at your y-intercept, which is right here where you see 1, 0, 1, and I go up until I can see, look on the line, where else does it cross at exactly an intersecting point on your graph? Right there. So I'm going to rise. What's it going to take me with a rise and a run to get from this point on the y-axis to the point that's up here close to in the second quadrant? So I'm going to rise up 1, 2, 3, 4. So I went up 4, positive, and over in a negative direction, 3. To the left is a negative direction. So I rose up a positive 4, and I ran in a negative direction 3 steps. So my slope is negative 4/3. So I plug that in for m, and I get negative 4/3 x plus 1, and that is the equation of line B. Number 8. Okay, I'm going to go ahead and write this down on the bottom here. Sorry, and it's going to make your eyes a little batty. Let's go ahead and put number 8 down here. We'll do it in blue to keep it separated. So the problem on number 8 is test 4, number 8. Okay, we're going to add this together. So we have 3 plus r over 3t squared. Okay, so in order to add those together, first of all, I notice I can't do a thing with it unless I have the same denominators. So I'm going to put that 3 over 1 for just a minute. So what is the denominator that I need to have? My 3 that I just put over 1 needs to have a denominator of 3t squared, like this one does over here. So how am I going to get that? Let's just multiply. Let me make this a little bit bigger. This by 3t squared. But remember, on a fraction, unless I change the numerator as well, I'm going to be cattywampus, right? I'm not going to be in sync. It's going to be unbalanced. So whatever I do to the denominator, I have to do to the numerator in order to keep that fraction an equivalent fraction. So we multiply both of those by 3t squared. Now I'm going to end up with 9t squared over 3t squared plus r over 3t squared. The beautiful thing now is that my denominators are exactly the same. They look better. Now I can just put those together. 9t squared plus r over 3t squared. And that's the answer to number 8. Okay? Let's go up here and see what number 9 is all about. Number 9 is not assigned. Okay, let's move to number 10. So number 10, we want to find the distance between 2 negative 3 and 5, 6. So I think what you guys did was you used the distance formula, which was completely fine. I'm going to show you how they showed this in the answer key. And in the book at this point, they hadn't shown the distance formula just yet. You guys learned that, I think, in first quarter in your geometry, perhaps in your geometry program that you were doing. So let me show you what Saxon was showing, another way of showing you how to do this. Either way is fine. You found it using the distance formula. You know how to get the answer. That's completely fine. But here's how we use it with the Pythagorean theorem. All right, so my 2 points, I'm going to plot them in a minute, but I'm going to write them right here. So I have 2, negative 3, and 5, 6. Whoops, 5, 6. So let's plot those. So I have 2, negative 3, and I have 5, 6. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6. 2, 3, 4, 5, 6. Okay, and I'm going to connect the line as best as I can. Sometimes it's hard for me on this iPad to do that. I can't put a ruler on here. That is awful. Let's try it again. Maybe I'll come down. All right, that's not so bad. Okay, so there's the line. Now, to find the distance between this point and this point, I'm looking for right here. This is going to be distance. So I'm going to call this, between those 2 points, we're going to name it D for distance. Now, I'm going to use the Pythagorean theorem to solve for this. Now, remember, the Pythagorean theorem is simply, think about this, because you're going to think to yourself, that's not a right triangle, Mrs. Quigley, but we can make it into one. So we know that one leg squared plus the other leg squared will equal the hypotenuse squared. All right, so let's draw ourselves. Let's make some connecting lines here just to kind of place in here. This is going to help us to fill in that formula. All right, so I'm going to figure on the bottom here of my right triangle. This is 3 units. And then the other leg is going to be 1, 2, 3, 4, 5, 6, 7, 8, 9 units. because that'll give me my 2 leg measurements, and all I need to find is the distance. So let's fill those in. So we're going to have 3 squared plus 9 squared equals, I'm going to change that c squared to the d for distance because it is on the hypotenuse. We'll square it. That's the hypotenuse representation. So let's figure this out. So I'm going to have 9 plus 81 equals d squared, which is 90 equals d squared. We take the square root of that, and I'm going to turn my d around. I'm going to put it over here. D equals 3 square roots of 10. That is the distance between those 2 points, and that is the answer. The distance between those 2 points is 3 times the square root of 10. Okay, the next one is 12. So let's bump up here and look at number 12. All right, on number 12, all you had to do there was, there's a couple things you can do. If you don't mind working with decimals, you can leave it just as it is. Or I think what we learned in Saxon, I remember in Algebra 1, and I'm going to just peek into the, we're going to do the same thing in Algebra 2 at this point. This is a review problem. So what we're going to do is we're going to get rid of those decimals by simply multiplying them all by 100. So when I multiply them all by 100, that's going to move my decimal point 2 places. Okay, so if I have, let's rewrite this right here. I'm going to go right below it. If I multiply everything by 100, it moves my decimal point 2 places to the right. So now I'm going to have 30x minus 30 minus 3 equals 33. So that would be our new equation. So I'm going to go to the bottom and write that out. And we'll work it out together here. 12. Okay, so I had 30x minus 30 minus 3 equals 33. So let's do our algebra and put some terms together here. I have 30x is my only x term. I'm going to go ahead and put the negative 30 and then minus 3 together. I'm going to have minus 33 equals 33. And we just keep working this out. Whoops. Let's add 33 to both sides of our equation to keep it in balance. 30x equals 66. We divide both sides by 30. And x will equal, you can put that in your calculator actually. 66 divided by 30 is 2.2. And that's the answer to that. So either way you do that, if you like the decimals, you can figure them out that way, but this makes it an easy way to calculate without having to use your calculator. It just makes the numbers whole numbers, and it makes it a lot easier to work with. And you can actually test that, though. If you did it with the decimals, you can test it to see if that turns out the same, and it should work out. Okay, the next one we're going to look at is number 16. Simplify by adding like terms. Okay, this is a big one, and actually I did this one in class as well, but if you need to see it again, I'm about to do it. I'm going to change my pen color to purple. And, excuse me, 16 is negative. Be careful, because I remember saying on the test it was hard to see that negative sign. At least it was for me. I missed it a couple times. R plus 5, p to the 4th, p to the negative 3rd, r to the negative 1st, minus 2, r to the negative 1, p to the negative 2. This is all over q. And this is all over p to the negative 3rd, q to the negative 1st. I feel better if I can say it while I'm writing it. Okay, so on this one, the directions simply state that we're going to simplify it by adding like terms. So we have lots and lots of exponents. Some are positive and some are negative. So let's talk about how we handle these. All right, on the first one, I'm going to kind of investigate, and it looks like there's really nothing I can do. There's no r's on the top, so I can't cancel it with the r on the bottom. So I'm just going to rewrite the very first fraction here. On the second one, it looks like I have a couple of p terms here that I can combine. So remember, think about this. If I had p to the second times p to the third, what would that actually mean? That's going to be p times p times p times p times p, right? Well, how many p's is that? That's p to the fifth power. So notice look at our exponents here. Looks to me then like when we multiply terms that have exponents with the same base, this one has a p as its base, we can simply add our exponents. Okay, that's just an example. So let's go ahead and apply that same method to our p terms up top here. So I have a 4 and a -3. So we simply put those together. We would have 4 plus, right? 4 plus a -3, or 4 minus 3, which is 1. So now we have 5p to the first power r. Actually, I'm going to move that r because it's got a negative exponent. So remember, when you have a negative exponent, you can move it to get rid of the negative exponent. Move it to the bottom. There's already a q down there, and we're going to move that r to the first power on the bottom. Okay? And then let's deal with this third one over here. So I have only one r term, but I'm going to put that r on the bottom. So I'm going to leave 2 as it is. Let me go ahead and get my line here. This r to the first power, I'm going to move on the bottom. And let's see what I have. Oh, and this q right here to the negative first power, I'm going to move to the top so I can get rid of the negative exponent. Okay, and you know we don't really need to put that 1 on there. Okay, because anything to the first power is simply going to be itself. But I do need to deal with that term right there. So I have p to the negative second power on top and p to the negative third power on the bottom. Well, let's think about this. If I had p, I'm just going to change this around just for an example. So let's say we have p to the third power divided by p to the second power. Let's think about what that means. That's p times p times p over p times p. If I canceled those out, I'm left with 1p on the top, right? So p to the first power, or just p, right? Well, look at the exponents. A 3 and a 2, and I end up with a 1. So I guess it stands to reason that if I add my exponents together when I'm multiplying a variable with the same base, then it would stand to reason that I would subtract my exponents if I'm dividing. So 3 minus 2 is 1. So let's look what we have up top here. Let me get rid of all that because that's not necessary to keep on there. Okay, so let's go back up to the problem. So I have p to the negative second power over p to the negative third. So I'm going to subtract those exponents. Now be careful because it's not negative 2 minus 3. Okay, it's negative 2 minus a negative 3, which ends up being negative 2 plus 3, which ends up being 1. So we end up with p to the first power, or just p. I'll put it there, though, just so you know how we got that. Okay? So is there anything I can combine? Well, actually, it looks like this fraction and this fraction both have the same denominator, so I can combine those two. Pay attention to the fact that this is a negative fraction, and it's subtracting a negative fraction over here. So be careful about that when you're putting those terms together. So I'm going to have a negative 3 minus 2, which is going to give me a negative 5. PQ over R plus 5P over QR. And that's the answer. That's number 16. Let's see what else we have. 2 more problems on this one and we'll be done. Number 17. We have an equation here, or an expression. Actually, it's not set up as an equation, it's an expression, but we want to evaluate it by putting in a y value and an a value. So for everywhere you see a y, you're going to put a negative 3 in, and everywhere you see an a, you're going to put in a 1/3. So let me go down to the bottom here and rewrite the problem. change my pen color. Number 17. And the expression written here is a squared minus ya minus y times a minus y. And we're told that everywhere we see y, we're going to put in a -3, and everywhere we see a, we're going to put in a 1/3. I highly recommend you taking the time to actually fill those in. Right below it, just fill those in. Don't try to do this in your head. There's a very likely chance that you're going to get it wrong because that's too much to retain. So we have all the y's. So I'm going to go from left to right. I'm going to put a 1/3 squared minus -3. Be careful. Don't put just -3 and think, oh, well, there's already a negative here. That takes care of the negative in my 3 over here. It's minus a -3 in for y. So minus -3 times 1/3 minus a -3 times 1/3 minus a -3. And that's how you would fill that in. Now we have some calculating to do. So 1/3 squared is going to be 1/9 minus, and I'm going to take care of these two terms first. I'm going to put this over 1. What's going to happen there? That's going to be, I'm going to keep it in parentheses so you can see it. That would turn out to be a -3 over 3. So that's going to be a -1 inside there. Minus, I'm going to leave this -3 here for just a moment. And then I'm going to put together here what's going on inside here. I've got 1/3, and I'm going to go ahead and just change this. I don't like to change too many things at once because sometimes that's how mistakes end up happening. Now I moved that 3 up there because I want to put it over 1. Okay, now let's just make this a little more simple. We're going to simplify it down a little bit further. So now I have 1/9, and this right here, a negative times a negative is going to turn that to be a positive. And I'm going to change this 1 to 9 over 9 simply because I'm going to need to put that term together with my 1/9 that I already listed. Minus. Now I can do some distributing here. So when I distribute -3, I'll put that over 1 so you can see it, times the 1/3, I'm going to get a -1, right? -3 times 1/3 is going to be -3 over 3, and that's going to be a -1. Oops. And then I'm going to take that -3 and I'm going to multiply it with 3. So I'm going to end up with a -9 right here. So let's put these together. So now I have 10/9 minus what's inside my parentheses, the -10. So what happens here? 10/9. It's a lot of writing, so try to write small so you can fit it all in. So now I have 10/9 plus 10, and I'm going to change this 10 over 1 to 90 over 9 so that I can put these two fractions together. And I'm going to end up with 100 over 9. And if you work that out, you're going to end up with 11 and 1/9. So you can choose to write it this way, or you can leave it that way. The answer key actually features it as a mixed number, but I would accept 100 over 9 as well. Simplifying it, though, this is really more proper format where you don't have an improper fraction. Okay, and then finally, the last problem was number 20. And on number 20, let's go up and look at it. I'm going to need a graph. We want to find the equation of the line that passes through these 2 points. So let's go ahead and get those points onto a coordinate plane right here. Test. So -3, I'm going to write those right up here. So we have -3, 5, and 4, 2. -3, 1, 2, 3, 5, 1, 2, 3, 4, 5 right here, and 4, 2, 1, 2, 3, 4, 2 right there. connect that. Our line. What are we trying to do here? Find the equation. Okay, so we want to find the equation of this line. There's a couple ways to do it, but I looked ahead because I was trying to see where we were at this point in the Saxon review. And we are going to still use the slope-intercept form to write this equation. So we're going to start with y equals mx plus b. Remember, m is the slope and b is the y value of the y-intercept, which means that's where it crosses the x or the y-axis. But when I look at the y-axis, it crosses right here. Let me put another color here. Crosses right here, and that's not right on an intersecting part of the grid, so it's hard to tell what that value is. So at some point, we're going to have to solve for b. So for now, let's figure out our slope. So I'm going to go from one point to the next. I'm going to pick this point that's on the line and this point that's on the line because those are right at intersecting points on the grid. So I'm going to go up. In order to get from this one over to the other one, I have to march up 3 in a positive direction. And I'm going to go to the left. 1, 2, 3, 4, 5, 6, 7 in a negative direction. So my slope, I'm going to write it right up here, is, remember, it's rise over run. So I rose up a positive 3 and I ran negative 7. So the slope is negative 3/7. So let's fill that part in. So we have, for the slope, negative 3/7. Now, I'm not going to fill in the rest of that at the moment because what we need to do is figure out what b is. So we're going to pick one of our sets of points here. It doesn't matter if I choose negative 3,5 or I choose 4,2. And I think in class today I chose the negative 3, 5. I'm thinking about maybe choosing the other to see how that works out so we can see that you can use either set of points. So I have an x value and a y value here, and I'm going to plug those in for x and y in my slope-intercept form. So y is 2 equals negative 3/7. X is 4 plus b. So we're solving for b. I need to know what that value is in order to write a correct equation for that line. So 2 equals negative 12 over 7 plus b. I need to change this 2 over 1 to something with a denominator of 7. So I would have 14/7 here. Let's just rewrite this so we don't lose track of where I am. I'm going to add 12/7 to both sides, which will eliminate it from this side and make it 26/7. Okay, so that is the exact same value that I got today when we worked it out in class. So now to finish up the slope-intercept form, I'm going to write it right here on my coordinate plane. So y equals negative 3/7 x times x plus 26 over 7. That's the equation for that line, and that finishes up test 4. So I'm going to end this video here. Hopefully you can find whichever problem you're looking for, and I'm going to go ahead and do another video recording for test 5 problems so you can check them there, or if you're getting stuck on any, you can look for the problem you need there. Okay guys, thanks for watching.